Hi guys, in this video we're going to talk about how fructose enters the glycolysis cycle in muscle and liver. In muscle, we have an enzyme called hexokinase that we encountered in glycolysis too, and the same hexokinase can convert fructose to fructose 6-phosphate, so that's for muscle pretty easy. But for liver doesn't have hexokinase, but it has an isozyme of hexokinase called glucokinase. And glucokinase has low affinity for fructose, so it cannot convert fructose to fructose 6-phosphate. So in liver, the entry of fructose to glycolysis takes place in 7 steps catalyzed by 7 different enzymes, and we're going to learn that right now. So the first step is catalyzed by the enzyme fructokinase, and in this reaction fructose is converted into fructose 1-phosphate by fructokinase, and in this process 1 ATP gets hydrolyzed to ADP. And you can see by the name of the enzyme, a lot of time you can predict what the reaction is going to be. Whenever you see a kinase enzyme, then the reaction would either include addition of phosphate to the molecule or removal of phosphate from the molecule to make ATP, if you guys have realized that. The second stage includes the enzyme aldolase, and in this reaction the fructose 1-phosphate, this molecule is open up right here, fructose 1-phosphate is converted into dihydroxyacetone phosphate and glyceraldehyde. And the way aldolase acts is it cuts up a molecule 1 carbon below the carbonyl carbon. So you can see that the top part of this molecule makes dihydroxyacetone phosphate and the bottom part makes glyceraldehyde. And in our third reaction, which is catalyzed by glyceraldehyde kinase, glyceraldehyde is converted into glyceraldehyde 3-phosphate. And in this reaction, I forgot to write it, but 1 ATP molecule gets converted into 1 ADP2. And like I told you before, whenever you see a kinase, a phosphate is either added to a molecule or it's removed from the molecule to make an ATP. So now it kind of looks like we got all the product we need in glycolysis. We have the dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. So the reaction looks complete, but we still have 4 more reactions, and in that reaction we're going to learn how glyceraldehyde could be converted into dihydroxyacetone phosphate, which will then be converted into glyceraldehyde 3-phosphate. In this reaction, in reaction number 3, the glyceraldehyde is converted straight to glyceraldehyde 3-phosphate, but the remaining reaction is going to talk about how glyceraldehyde would first be converted into dihydroxyacetone phosphate and then to glyceraldehyde 3-phosphate. It might look scary, but it's not that scary.